So thank you everyone for joining us in our quarantine version of our seminar series for ideas. Today, we are absolutely delighted to have Jake Shapiro talking to us. He is coming from Princeton University, where he is a professor of politics and international affairs. One of the things that he does is he takes a kind of computational social science approach to studying things that matter from a political perspective, elections, COVID-19, et cetera. So that means that he's bringing together, very high-end computer science techniques with very, detailed qualitative analysis at times, blending them, and then addressing these major issues. Today, he'll be talking to us about some early results dealing with COVID-19 and the pandemic. With that, Jake, take it away.
Awesome. Thank you, Kathleen, and thank you for the kind introduction. And thanks to everyone for joining for this. What I want to do with our time together today is basically talk through the agenda on this slide. So the first half of the talk, we'll talk about some work that the ESOC group at Princeton has been doing around COVID-19 misinformation, talk a little bit about some of the relevant social science and some of the patterns we're seeing in narrative, and then we'll pause to discuss that for a little bit. And then we're going to pivot to some work we've been doing for the last year to build out some tools for content-based detection of coordinated online influence efforts. Our primary interest in doing that was understanding things that nation states were doing when they were reaching out and trying to influence politics in other countries, and basically doing a proof by example of the feasibility of detecting that kind of industrialized activity. And so I'll show you a little bit of what we built, and then we can discuss that and the things that we can learn from it. Because in the process of doing all the kind of detection work, we're kicking off all kinds of features which are relevant for understanding what's the underlying strategy and production process for those influence campaigns. So that's the agenda for today. Let's start by talking about COVID. So the first thing to say in thinking about COVID, and the screen is black on purpose, is just for a minute to think about where we were around March 15th. I was actually flying back from Ecuador and came back to learn that a good friend had been put in charge of the misinformation response at one of the large tech companies. And we had a group of research assistants at Princeton who had a lot of experience working on influence campaigns. And so I thought, gosh, someone should start just cataloging the narratives that are out there around this. So we quickly pulled together the team that you see here of students and researchers at Princeton University and a bunch of places around the world to start to try and catalog the range of narratives. And what I'm going to show you today is some evidence from that. It's important in what we're going to look at to maintain the distinction between what is a narrative and what is the volume of content. One narrative can be shared many times, and we're not trying to quantify that. We're not doing that kind of work here. What we're doing is just measuring basically the breadth and variety of the different narratives across a whole bunch of different countries. And if anyone, by the way, knows someone who would like to do this for Indonesia, that is a country that we are missing. Okay, so what have we done with each narrative? So as we go through and we're looking at the reporting on COVID-related information, we're basically taking the different narratives and we're binning them up in different ways. So we're thinking about what type of story is the disinformation pushing? From the context and from the reporting on that disinformation, what can we infer about the motive behind it? So is someone trying to profit, shape domestic politics, et cetera? And we'll talk about that in a little more detail when we get to it. And then who is responsible? And so what we want to be able to understand is things like, of the narratives out there that are being pushed by state sponsors, what's the distribution, right? What kinds of stories are they talking about, and how is that different from what individual actors are talking about? We've been putting all this up into a nice online database that's accessible on the ESOC website, and happy to send out the information to download that for anyone who wants it after this. The idea being that in this data, you have both the URL where it is reported on, the source of the disinformation, whether that's an URL, a tweet, a WhatsApp, whatever, and then a bunch of information relevant to when it went up and whatnot, which could be useful for all kinds of applications, seeding machine learning algorithms, various things like that. I want to be very clear, we are not unique in doing this. One of the things that we've included in the database that we've put up is we're keeping track of all the various online resources that are available for this. This is just a snapshot of what that looks like. We found so far 38 awesome data resources that people can use, all kinds of things from like state level data on incidents to protective ordinances, to people pulling together like location data from location service providers for technology companies. There's also, you have to name check this wonderful GitHub project by Nathan Matthias and colleagues, which is basically pulling together a list of all the research studies going on COVID. Right now, this Google sheet that they've put up has 213 studies in it as of this afternoon. So if you want to go and make sure that you're not doing something that someone else is doing, it's all right there. So before I show you the data, I want to talk for a minute about what the relevant social science says about how worried we should be about COVID-related misinformation. And it's going to be kind of like a good news, bad news story. And I'll give you the bad news first, which is that there are a lot of reasons to be worried. Some recent Pew research suggests that in the United States, 80% of adults go on the internet to find the information that they need on health-related issues. And that should be worrying because this is where most of the misinformation is circulating. In the case of the Ebola epidemic in West Africa from 2014 to 2016, there was a very strong correlation between the intensity of the epidemic locally and the level of misinformation that was spreading around it. Basically, Ebola casualty rates were significantly higher where there was more misinformation circulating. And in the case of the US, in most flu seasons, where there are deaths among children, they tend to be children who are not vaccinated. And we know that's correlated with consumption of anti-vax information. So that should all make us worried. And recent work by the Oxford Internet Institute team suggests that we shouldn't be too complacent about platforms taking this stuff down. So they took a sample of 225 pieces of false information rated as such by fact-checking organizations. And they just went to see, by First Draft News, they just went to see how many of those could they then find in their feeds on Twitter, YouTube, and Facebook. And 59% of that content was still up on Facebook when they went to look for it, despite having been reported in First Draft News, which is like readily accessible. 27% on YouTube and 24% on Facebook. All of which, again, have access to that data and have phenomenal teams to do all kinds of machine learning on their content to sweep out different kinds of information. So that should make us worried that people go to the web for health information. In the past, misinformation has harmed the public health response, and the platforms don't seem to be taking it down. And it turns out that there's some very interesting new work on susceptibility. So this is, these are a couple of the key figures from new work by my co-author, Austin Wright at University of Chicago and his colleagues. This is work that's under review where they just look at who is responding to county level stay-in-place orders, which are put in place before there is a state level order. And so what these graphs are showing you is they're showing you the event study for the change in social movement measured by UACT, one of the common movement service providers, on days before and day of county level stay-in-place orders, which are put in place before state level order. And this is controlling for state, county, and time fixed effects. So this is like the instantaneous response in a county on average to that order. And then what they've done here on the top row is they've just plotted the difference according to that top bar there is counties that are above median Trump vote share, basically the red counties in the map on the upper right panel, versus in below median Trump vote share counties in blue on the map. And what you see is that the county level stay in place order, which happens on day 0 ordinance, drops average movement significantly in places that voted for Clinton in 2016, and does not do so in places that voted for Trump in 2016. You can do the same thing with counties that are or are not exposed to a local Fox News station owned by Sinclair Broadcasting, which is known for pushing kind of right-wing content through its local stations, and you see a similar difference, and that's after controlling for the partisanship of the area. So this should make you a little bit nervous that the partisan difference in the way the epidemic was talked about, or the pandemic was talked about, particularly early on in March when these county-level stay-in-place orders were issued, it definitely mediated the level of responsiveness to public health calls from politicians. So that should make you nervous. So why should you be hopeful? I think there are a few reasons to be hopeful. The first is work by my colleague Marcus Pryor, which takes the well-known fact that economic assessments are heavily partisan biased. So in the same period, if you ask a Democrat and a Republican how the economy is doing, if there's a Democrat in the presidency, the Democrats will say it's better than it actually is, and the Republicans will say it's worse. And that flips when there's a Republican in office. What Marcus and colleagues did is they showed that you could completely kill that partisan bias with small payments for getting the answer right. So it turns out, in their interpretation, what we had interpreted as people don't understand the world and they interpret it through this partisan lens was actually people expressing themselves in the context of surveys. And if you gave them a little monetary incentive to get it right, they got it right. If you think about the incentives that are created by a deadly pandemic raging through society, one would hope that would have the same effect in terms of mitigating partisan bias. And it turns out that there's also very good evidence that small interventions, which increase trust in health workers, can dramatically improve the public health response. So in Sierra Leone, our colleagues Bilal Siddiqui and Andrila Dubé have done work where they were out in the field before the Ebola epidemic with basically work that was increasing, an RCT that was increasing trust in local health workers. When the epidemic hit, the places that were in their treatment communities, where there had been an increase in health worker trust, experienced much lower mortality rates than other places. So their activity dramatically improved the response. And there's good evidence that fake news exposure is actually quite low. So a new paper by my colleague Andy Guess and colleagues shows that basically, if you look out across like all the different websites that people access for political news, less than 6% carried fake news in 2016. And recent work with political data on Twitter shows that only 6% of the news that people consumed on Twitter in the lead up to 2016 was fake news. And 1% of users accounted for almost all of that exposure. And 0.01% of that, 0.1% of that were responsible for 80% of the sharing. So not a lot was seen and only a small portion of people engaged with it. So that should make us like a little bit hopeful. Okay, so what do we see in terms of narratives? What this plot shows you is for the 394 narratives that we've identified so far. This is just the number reported on any given day. And what you should take away from this is that as the pandemic becomes severe outside of China, media reporting on it goes through the roof. And there's a little bit of bias here because like we start the coding process around March 16th. So the coders were super enthusiastic and started to kind of really engage. But you can see this clear upward trend and a level shift after mid-March in the amount of narratives that are being reported on. What's the distribution of these narratives like? So we break them up into these different categories. Are they about the emergency response, false cures or preventive measures? The nature of the virus is things like both whether it's infectious or not, but also things like, you know, is it like punishment from God for the sins of the people, or is it a biological organism? So things like that. Weaponization or design can be thought of as a subset of that. These are the narratives that it's, you know, something that escaped from a Chinese bioweapons lab, or the United States is spreading this to reduce China's influence in the world. Origins of the virus are stories that are specifically about origin that are not weaponization or design. So you could think about stacking those two up as one category, and that would be the largest kind of misinformation. And then there are stories on the COVID-19 status of individuals or false diagnostic procedures, and then a range of other things. Fortunately, the false diagnostic procedures mostly seems to have gone away. We're not seeing any more creative things like, you know, hold your breath for 10 seconds. This next plot shows you basically the the motives for COVID-19 misinformation, and unfortunately has a slight typo on it. So let's correct that. There you go. So the vast majority of these fall into two areas. One is this broad other category, which we're working to disaggregate, but that basically combines two key subgroups. The first is people who are genuinely trying to be helpful and are sharing what turns out to be misinformation because they think it's useful for their community. And then the second is people who are just trolling in the classic sense of just trying to mess with an online discussion. The next largest category is people who are trying to spread fear about the pandemic, so exaggerating its severity or the risks or what it's going to mean for society. And then you have these kind of two categories of either trying to influence politics by attributing it to a particular individual or trying to discredit particular institutions in a target country. And almost all of the activity in terms of narratives that seem to be coming from nation-state actors fall into that fourth category of undermining target country institutions. It's basically, for the most part, Russian and Chinese operations that appear to be targeted at discrediting American and European Union institutions. And then there's a small amount that appear to have a profit motive. Now, this is a point to stop and highlight. This is not the volume of content that is out there. This is like the range of narratives. So some of those profit-motivated narratives may show up again and again in huge volume in social media or in people's web search, but as like the share of narratives which we see, it's quite small. These are some examples of the kinds of stories which fall into each narrative. And so you can get a feel for what these are. You know, the thing to highlight here is, you can all read this, so I'm not going to read them to you. But there's a lot of variety out there. And there's not kind of any, like each of these is a highly diverse category. So one thing which would be potentially very interesting for someone to take on is to think about these as a set of base categories and like diversity within categories over time. And for example, I've told you the profit category is not that significant in terms of the diversity of narratives. Understanding how much of the volume that is could be quite important. Okay, as far as who's producing this stuff, as far as we can tell, it is almost all individuals. We see very little evidence that there's a diverse set of narratives being pushed by state sponsors or by political actors. Political actor would be like a politician not representing a nation state, but acting in their own capacity. It really does seem to be individuals promoting this either for fun or profit or for political goals. Okay. So some preliminary conclusions, some things we're seeing, and then I'll take some questions on this part of the talk. We are definitely seeing a resurgence of chain messages and direct peer-to-peer communications. Of all the stories that we've collected, this slide, sorry, that number isn't updated from the last time we gave this talk. 36% as of about a week ago of the collected stories were found on chain mails, WhatsApp channels, not actually in the media or on social media. Like broadcast social media like Twitter. Motives tended to be fear or other. And, you know, a lot of this was like what seemed to be well-intentioned activity. So people sharing with their friends things that they thought might be useful. The other two things I've already talked about, there really has been this very aggressive response from it. You know, in that, from the media, in that resource tab, which I mentioned earlier, there are 7 or 8 different fact-checking services around the world which are making all their data public, and we're finding new ones all the time. So we had a call with the RAs on Monday, and we learned that a group of journalists in Nepal, for example, has set up their own fact-checking service to provide information on what is false that is going around in the Nepalese media, so that as the pandemic becomes serious there, people are aware of the situation. So I'm going to pause there and stop the screen share so people can see me if they want to, and take a few questions, and then we'll come back for the second half of the talk.
Hi, Dr. Shapiro. I just have a question. I have 2 questions relating to the methodology. In the first case, when you went to go and collect these stories from the various sources, what was the search procedure you used? Was it just typing keywords in? And then for the second question, when you went to code the different stories, was there like a given code book? Was this a grounded theory thing? How did that process work?
Yeah, great questions. So on the search procedure, there are basically two main categories of things that we've done so far. One is we've gone through and we've hit the high quality fact checking sites that are out there where they're just like, where they're kind of like building lists online of things they're finding. Like AFP has a wonderful site where they go deep on each fact that they check and try and provide counter reporting and like a little one-page story on each. So we're pulling all that information in for the ones we've identified. And then we're allowing the RAs in different countries to work according to their knowledge of the local social media and media environment. And we did that up to this point because our goal was not originally to be representative. Our goal was to wrap our arms around what the range of the narratives were that were out there and to create examples which could be used by folks at the platforms or other places to feed machine learning algorithms, which would then generate candidates for their armies of folks to look at more closely. At this point, now that we've got people working in multiple languages, we are working on refining those procedures so that we can get to a point where we know of what population is this representative. But we're not there yet, and it's a bit of a tricky problem because the resources for scanning the media are somewhat diverse across countries. And we have a little bit of mismatch between the linguistic capability of the research folks and who has access to things like Factiva or Nexus Uni or things that would give them the ability to do really structured Boolean searches. As far as the code book is updated, has been updated on a multiple times a week basis as we go through this, as we learn more about the space and how to encode it in structured and useful ways. What we've been doing is with the data, there's a code book. We're now on version 2.3, and each version basically logs the changes from the prior version. So for example, in version 2.3, we introduced a distinction which the coders haven't finished implementing that breaks that other motive category up into basically people who are being helpful and trolling, and then the kind of remaining residual category. So as they go through and institute those rules, that's noted in version 2.3. It wasn't in version 2.2, and there's a little thing at the bottom which says, hey, here are the changes that we've made. So we're trying to be like maximally transparent without letting the perfect be the enemy of the good. Okay, so the second piece of this talk is joint work with Mesam Alizadeh, who's a research scholar here at Princeton. And it basically took off from this work that Diego Martin and I did back in 2019, where we basically worked with a group of RAs to build a database of all the times that one country had reached out into another country's politics and tried to manipulate them by creating fake media content, which was designed to appear as though it were organic to the target state. And this kind of shows you what that looked like through 2018. We're in the process of updating this for 2019 now. In 2019, we observed another 19 such campaigns. So the rate of arrival definitely increased in 2019 compared to 2018. A lot of that was the diversification away from Iran and Russia, who were the primary proponents of such campaigns, or the primary countries activating them through 2018. In 2019, you see this kind of diversification of the effort, and you see lots of countries begin using these techniques on their own population. This is things like what the Internet Research Agency did targeting in the 2016 election in the United States. I was working on this report, and Mesam had arrived at Princeton, and we were thinking about what we could do which would be useful for addressing this problem. And so we asked ourselves the simple question of, well, like, how distinctive is this activity? I mean, after all, these are like industrialized campaigns where you take an office building full of workers and you have them, you basically have them, I realize I'm not sharing the screen here. You basically have them go out and start producing mass amounts of content to project out into another country and try to convince people in that country that politics should be something other than what it would naturally be. And we thought, gosh, in that production process, if you want to move politics, you need to do one of two things. You either need to produce things that are different than what normal users are producing, or you need to produce a lot of content. And if you're going to produce a lot of content, with the kind of relatively low-skilled labor that you can get as a government contractor, you're going to need some things like standardized templates, SOPs for your workers, and you're going to need to make it like easy for an individual to manage 50 or 60 different accounts and handle that content. And that's going to impart some characteristic signal into the content. So it seemed to us like there should be a very obvious difference in the content that's part of these coordinated campaigns from organic social media activity. So with that insight in mind, we set out to build what we thought was like the low baseline for a content-based classification system. The idea being that however well this thing does, and the schematic of it is here on this slide, however well this does, that's like the lower bound on what you could do with machine learning. Because all we're doing is we're taking the troll data. I'll show you some stuff from Russian, Venezuelan, and Chinese trolls. We're mixing that in with activity from random users and politically engaged users. We're extracting from that a unit of analysis that can be classified, in our case, the post-URL pair. And the instinct behind that is when a post has a link, the thing a human being does to figure out, like, is this a normal political user or is this a troll, is they look at the language, what they're saying, and the content they link out to, and they ask, is that like abnormal or not? Is the combination of those abnormal or not? So we're going to take those as the unit. We're going to bring in a little bit of external data in terms of like things that are going on in society, and we're going to calculate meta features, which I'll talk about in a minute. And then we're going to end some things like, you know, a list for different news domains of like what kind of news website is it? Is it a sports website, mainstream, right-wing, etc.? We're going to bring that in, and then for every post, we're going to generate this rich feature vector of about 1,050 features. Things like the nature of the language that's used, whether a hashtag that they cite is among the top 50 hashtags promoted by trolls, things like that. And then we'll just throw out-of-the-box random forest at it and see how well we do at separating troll activity from organic activity. So think about this as establishing a common machine learning baseline, and then asking how well this set of features distinguishes different kinds of content. And we wanted to understand this not in the context of any one fixed classification task, but across multiple classification tasks. So what we did is we said, let's think about doing this in a few ways which are different from prior activity. So we wanted to focus on content as opposed to users. That was like partly a practical choice, but also partly a choice because in an operational setting, it would be nice to have something which didn't require like saying, look, this particular user is in fact a troll, which opens you up to all kinds of liability and other things, and stymies the public relations piece, because for sure, if you're doing probabilistic classification, you're going to get it wrong sometimes. We wanted to have something that we could test on detecting future activity. So you have some set of forensic processes which let you know what is troll activity today. We wanted to know how well could you predict in tomorrow's content what is part of their campaign versus what is not. We wanted to bring in this external content, so other things that we know about the world, like is this domain one that has like legit news or not on it. We wanted to make sure that we were classifying versus representative samples. So we worked with Josh Tucker and Cody Buntain, who was then at NYU, to grab a representative sample of American Twitter users and representative sample of politically engaged users so that we could test the classifier in kind of an operationally relevant setting. We wanted to think about very short training periods. So in what I'll show you, we're going to test with only a month of training data on multiple periods. And we wanted to use human interpretable features. So that's kind of what's new and different here. Before I show you the tests we did, I want to talk for a minute about this idea of meta content. So this is an example of a tweet. It has some content in it, some text, man shot to death in luxury SUV in the Bronx. And then it has a shortened URL. So that expanded URL is just below. And so content is things that are directly about this tweet and this URL. Right? So the number of words in the body, whether it's a retweet or not, if the URL is shortened, things like that. The meta content is features of this post-URL pair that only can be figured out in relation to all the other content that's out there. So does it include a hashtag that is among the top 50 used by trolls? Does it reference a local news website? That requires a listing of what are local news websites, which we have. Does it mention a politician, a journalist? Is it a top website? These are all things that are kind of the context, but that tweet lives within that context. And so those features are possibly relevant for classification, particularly if they're being produced by a large organization where the boss one day says, hey guys, I heard Americans like to talk about local news websites. Here's a list of local news websites, cite them in your tweets. Because that's going to make them look more normal. That's like a thing that could go on in the industrialized production process, and we want to be able to pick that up. So with those different kind of features and that very basic setup, we set about looking at these 4 different prediction tasks. Sorry, not predication tasks. The first task is kind of a standard one. You take a given month, you make a train test split. In our case, we're going to do 50-50. And you want to predict for the part that was held out, which posts are by trolls and which ones are not. And this relates to the real world scenario where you have like data on half of the accounts that are part of an influence campaign, and you want to find the rest of it. So think about that as like the easy baseline task. The kind of next step up in difficulty would be to figure out what is part of that campaign in the next period. And the simple way to do this, which makes the job like, in some sense, artificially easy, is you take the data in month T on the trolls and the normal users, and you estimate a model. And then in the next month, you try to predict out which ones are trolls and which ones are not. But in some sense, that's like a little too easy of the future prediction task, because you already know in the next month, like who a portion of the trolls are, because you did your forensics on them in this month. So task 3, the kind of next step up in difficulty, is in the next month, can you separate out the trolls which are part of the given influence campaign, which had never before been active, from normal users, using the data on the accounts which were being used as part of that campaign in the previous month. So this is like a test of like, how much are the SOPs, the standard operating procedures, the rules for how the trolls in that campaign operate, how much are they giving you signal that lets you distinguish new accounts they start working in the next month from normal users? And then the last test, and in some ways the hardest, is to say for the 2 campaigns where Twitter has released data at 2 different points in time on the things they found, of the accounts which were active during the period covered by the first release, which they missed, how well would you have done at distinguishing those from normal activity? So Twitter releases these 2 big dumps on the IRA. A number of the accounts in the second dump were active in the period covered by the first dump. So we're going to ask, how well would you do at finding those accounts in any given month? This is kind of like asking, how well do content-based features complement the behavior-based detection approaches which they were using? Okay, so we're going to do this on multiple different campaigns. So this is just summary of the data. So we're going to look at Chinese, Russian, and Venezuelan campaigns on Twitter and the Russian campaign on Reddit. So 4 different influence campaigns. For each of them, we have different control data. So 5,000 political and random user accounts on Twitter. And then for Reddit, we basically took all the accounts that were on political subreddits and the top 30 Russian targeted subreddits, because part of what they did was talk on subreddits that weren't necessarily political to try and build up karma and influence. So this slide just gives you a summary. We're running each of these tests in every month for which we have data. So you have 4 tasks. You have monthly tests on each of these 4 tasks. And so this gives you a sense of the average F1, so like a reasonable performance metric, you know, the harmonic mean of precision and recall, across multiple months for each of the tasks on each of the different campaigns. Some of them, task 4, you cannot do for the Chinese campaign and the Russian campaign on Reddit, or at least you could not do it when we did this test. Twitter has released more data on China since we wrote this paper, and so there's an opportunity to do that now. But what you can see is generally the Russian campaigns are the hardest to predict. The Venezuelan campaigns are quite easy, and China sits somewhere in the middle. These are averages over multiple months, and so it's worth thinking about what more could you do to understand this and how well this kind of thing performs. Because if you look over time, there's a lot of variability in performance. So what these plots show you is they just show you the F1 score in every month of test for the Russian campaign on Reddit and the Russian campaign on Twitter over time, and then the number of trolls in train and test sets on the bottom. Now, it's hard to make a lot out of these because the performance is moving around quite a bit. So what you can do, sorry, this is on task 3, finding the content that is new, which is part of that campaign, which had not been previously identified. So it's a hard test. One thing that you can do is you can take each of these months of prediction as a separate experiment, and then you can ask what determines the performance of this classifier. So in the title of the slide there is the estimating equation that you would use to do this. So the YIT is some performance measure, precision recall, or F1. And then you have a set of CI, those are fixed effects for which campaign. Then you have the TI, which is a set of time controls. So to control for the TI are the characteristics of a particular effort. So that is like which platform is it? The XIT are time varying characteristics of a campaign. So the retweet share of a given campaign is different in every month. The reply share is different in every month. And then you have the sigma T there, which are characteristics of the political environment at any given point in time. So that's a count of major political events, and the severity rating of those averaged across for people knowledgeable about US politics. So what this gives you is this gives you a way to kind of estimate what is driving performance. And rather than show you regression tables, I'll just show you this, where the baseline is so this is just for the Twitter campaigns. The baseline here is going to be the Russian campaign. And once you account for all those features of the campaign, it turns out that the reason Venezuela was so easy to predict is that it had certain features which made it easy to predict. Once you control for those in that regression that I just showed you, the Venezuelan campaign is like a little bit harder to predict than the Russian one, but not significantly so. That next block of coefficients, task 2, task 3, task 4, that just shows you how much harder in terms of prediction each of the tasks was. So remember, the baseline is cross-sectional prediction within a month. The next task is predicting in the next month, including the accounts that were active in this month. And that's like a little bit harder. Significantly harder is predicting in the next month the accounts that have never before been active. And then the hardest, task 4 there, is predicting across campaigns. You can then look at the different features of the communication activity in a given month. And the thing that is kind of important to think about here is when you look at the reply share and the share with mention, it's going to turn out that for the Venezuelan campaign, the thing that made them really like distinctive was that they tended to really be heavy on the replies and rarely mention individuals. So you're picking up a lot of that. Features of the data seem to matter, but not massively. So the share of the positive examples in the test set is quite important, and class imbalance is quite important. The more imbalanced the class in the test set, turns out the better the system performs. And interestingly, the more severe the events are in a given period, the worse the system performs. And we think that's because what happens when there's a big political event is that the other users jump in and start talking about it. So that's kind of like what makes it hard to predict. The next question you might want to ask is, which features are important, right? How much can we get in terms of performance with this baseline machine learning approach only from content? And what this table shows you is for each of the tests, so task 1, task 2, task 3, task 4, how much of the performance in the full model, which is in column 5, do you get as you march across the different features? And it turns out that you get almost all the performance which you'll see in that full model in column 5 only from content and meta content. You don't need to worry about things like when did it go up, like what day, what time of day did it go up, how long has the user been around. That's helpful but not critical. Or the network features of the activity, which are incredibly hard to produce. Like most of the information is just in the content itself. And in some sense, that's what you would expect if the process of producing the content was a really like left this mark, because they have to do large volumes or be very different. Okay, so hopefully you recall that when I showed you those performance numbers from before, across all the tasks, the F1 scores for Venezuelan activity were much higher than for others. And this gets into a little bit of how could one use this system in other interesting ways. So what this shows you is for the Venezuelan campaign on Twitter, a number of features of the campaign over time in the 4 time series plots. So the ratio of hashtag to tweets, ratio of tweets with mention to tweets to all tweets, retweets to all tweets, and tweets with an URL to all tweets. And what you'll notice in those 4 plots is the Venezuelan campaign was not very consistent in how they operated. There are these clear moments in time when someone came into the office and said, hey guys, you need to use hashtags today. And sometime in July 2017, someone said that. They started to push out a lot of hashtags. And then it looks like in August, at some point, a manager came in and said, hey, cut out the hashtag stuff, and people just stopped. So that is completely different than how normal users would behave. And if you then look at the things that they are sharing and the things that they're retweeting, their retweets and shares were incredibly more concentrated than for normal users. So it became very easy to pick them out because of that, because of those features of their content. So that's kind of the first thing to think about in terms of why it was so easy. You can also look at the network structure of their activity, and it was just very simple. So on the left is the network structure of the Venezuelan activity in terms of the retweet network, and on the right is the Russian activity. And the difference is quite obvious. In the Russian case, there was a lot of effort by their accounts to not just kind of like retweet the obvious things, but to mix in political activity with normal activity. That was completely absent in the Venezuelan case. And so it again created this signal of difference between what they were doing and what normal users were doing that was just very easy to pick up. The other thing that you can do with this is, because we're using random forest, we get for free the variable importance measures. So what you can then do is, in any given experiment, in any given month, you can think about that as an opportunity to ask the question, what distinguishes this activity from normal activity? And that turns out to be very dynamic. And so this plot just shows you for 9 of the most important features, the variable importance measures over time for the Russian campaign on that 3rd task of like finding the accounts that they're introducing in the next month based on activity in this month. And what you see is that, for example, there on the upper left, early on in July 2015, the fact that they include in a post someone who is often mentioned by other trolls is quite discriminatory, because they're promoting basically mentioning people who aren't often mentioned by others. that becomes less important as you go on. But if you step over 2 graphs to the top mentions with a far right URL, in late 2015 and early 2016, a thing which started to discriminate their activity was that they often mentioned people who were prominent in far right URLs. So they're kind of like, they're mentioning those far right websites very often in ways that they had not before, and that distinguishes them from normal users. You can kind of look through and see these things distinguish them at different points in time. I want to give you like a little bit of a feel for what this looks like. If you look here and you see this top troll hashtags feature, that becomes quite important in September 2016. So this in September 2016 shows you the hashtags that are prominent among troll and regular users. And you can notice a very obvious difference in the distribution, right? The trolls, much more than the control group, talk about MAGA and are much less likely to use the hashtag debate night. So this is September 2016, when that feature is highly discriminatory. If you step forward to November 2016, when that feature is no longer discriminatory, you see that the distributions look much more similar. And so what this is basically doing is you kind of think about what the classifier is doing. It is giving you a sense at any given point in time of in what way is their activity abnormal. And then you can do all kinds of other analysis with that. Okay, so I'm going to stop there and take questions, because that was a lot in 20 minutes.
Hi, so I have a question, and that is, first off, this is like mind-boggling in some ways, but can you speak a little bit about how these techniques could be used in the next election ahead of time and on the fly?
Yeah, absolutely. There are several things one could use this for. So as long as there are active forensic efforts going on by people like Ben and the team at Graphica or DFR Labs or within the companies, one could take this approach, take the things that they are seeing or any other group, apply it to subsequent activity, and get 2 things out of it. One is you could get a principled estimate of the total volume of effort. And then because you have these post-URL pairs being classified, you can generate estimates of the topics that are trending among the trolls as compared to other groups of users. Because in another piece of this work, we've been applying a set of topic models over this content, and it works pretty well. You get nice coherent topics. And so that you can look at the trends within different groups of users. So all you need to kind of make that available to the public and to the news media is you need that some group of people be doing the forensic work, and there are lots of groups doing that. And then you'd be able to ingest that along with a nice sample of other users, and then you can apply this approach. And the F1 scores that I showed you are not terribly like super impressive as far as like machine learning on social media, but we haven't tried to optimize the machine learning stage at all. Right? That's like straight out of the box random forest. And so if you imagine doing various things to improve the quality of the classification step and maybe deepen the featurization a little bit, you could actually get like quite precise estimates. What we have done is we've tested how robust this is to false negatives and false positives. And it's quite robust to false negatives. So as you basically hide trolls from the algorithm, the performance degrades very smoothly in any given month. And we've done some work to see how robust it is to false positives. And we know it's robust to small numbers of false positives. We don't know that it's robust to like large numbers of false positives. But when we started this, what we wanted to do was put up a public facing dashboard for 2020 saying, here's how much content there is. You know, we're, in some ways, I think we've run out of time for that. Although if we had partners who wanted to move aggressively on that, who had some more infrastructure, we could totally do that. Certainly feasible.
Hello, hi, thank you for a very nice talk. I just have a question. I saw one of the slides showing the F1 score for the Twitter, and it looked for me that one of the platforms had higher F1 score than the other. So did you do any further investigation whether the nature of the platform would increase the F1 score and would be better for prediction or not? Like, for example, maybe because of the length of the tweet is definitely shorter than the Reddit blog or something. Yeah, actually, I think the coming slide where the one before or after. Yep, this one. So actually, it looks for me that the Russia Reddit is, in general, the F1 score is less than the Twitter score. So did you try to investigate the nature of the platform and how it brings better prediction or not? I'm sorry, I cannot hear. I'm not sure if.
Sorry. The reason the F1 is so poor for Reddit for this one in kind of April and kind of May 2017 onwards here is this is the test where we're trying to identify the accounts they have never used before from the accounts which were active in the previous month. And they're just introducing very, very few new accounts. You can see that with the number of trolls in the test set. This is the, you know, in thousands there on the bottom. And you can see they're just introducing very few new accounts. And so it's just, it's a rare event problem. It's just very hard to classify on Reddit during that time period. It is true that there are certain features of Twitter which don't exist in Reddit. But and so maybe you have a little more information to work with. But I wouldn't make too much of this particular one, because like what you would need is you would need to answer the question you're asking, you would need to focus on time periods when there is similar volume of activity by them on both Twitter and Reddit. And if you look in the period kind of July to December 2015, when there's more activity in Reddit, and you look at the analogous period on Twitter on the right, you see the performance is actually not that different. The F1s are, you know, kind of in the 0.7, 0.8 range.
Great, thanks.
Totally.
Again, thank you for the presentation. I wanted to ask what is the process that, or the inspiration of how you came up with all of these features? How did you decide, you know, like number of retweet hour of this, or these types of, what was the engine process to develop the feature set that you use?
It was asking Mason to think about features that he thought would be useful. Like, all credit to him on the feature selection process. I mean, to you know, to kind of to give a more precise version, you know, we thought about what were the pre-existing algorithms for things like language, content, tone. What were the obvious things like word count and whatnot. And then we started to think about, and again, really, like, he spent a lot of time thinking about, in the investigative work, what are the things which people use as a signal? And then what is the automatable, scalable version of that thing that the human is doing, which we could capture? And so the idea of looking at, is this one of the domains which they happen to be promoting in this month, came in part from the observation that it seems to be very trendy where they point people. And so if it's trendy where they point people and it's trendy in a different way than normal users, then if a user in this month is pointing people to things that the trolls were differentially promoting the last month, that might like increase your suspicion a little bit. And then you multiply that across lots of different kinds of meta content, and you quickly get to, yeah, this is probably a troll tweet. Does that help?
Absolutely, thank you.
And in the paper, which is under review now, we have like a big appendix which lists all the features.
I can imagine if it's if their feature space is that big.
Hello, can you hear me?
Yeah, loud and clear.
First of all, thank you for a tremendous presentation here. This is great research. The question I had is kind of regards to your data sources. I know for both Russia, China, Venezuela, that for example, Twitter has suspended and released data on all of those nation states. Did you use that? Obviously, that's suspended. So those accounts aren't producing anything going forward, but how did you get your labeled, and I may have just missed that, but how do you get your labeled data? Did you leverage that data that they've suspended and released at all in the process?
Yeah, I did a terrible job of explaining that, so apologies and thank you for asking. Yeah, these samples of troll users all come from the Twitter data releases. And this is all kind of like, for external validity, you have to think that they've been more or less comprehensive. So that's where the label troll tweets came from. And then the SMAP lab at NYU, Josh and Cody's team, has built out these samples of representative American Twitter users and representative politically engaged users through the kind of Twitter equivalent of random digit dialing. So they randomly generate handles, they check whether they exist, they check where they are, they check who they follow to figure out if they're politically engaged or not, and then they get that sample. And so they've been doing this, they've published on this a bunch, so it's kind of like well validated. We just grabbed 5,000 of each for this process because we wanted to keep the data relatively manageable.
So hi, David Breniatevsky here. Yeah, this is really cool work that you guys are doing. And I just sort of wanted to follow up on Kathleen's question regarding how you might implement this and what you think the half-life of it would be in practice. Because I wonder to what extent trolls are aware of their own, the extent to which they do or don't overlap with other users' behaviors, and whether putting forward a sort of sources and methods technique in public might actually lead them to adapt to it a little bit faster.
Yeah, those are great questions, David. And I think as far as the half-life, we've done two kinds of experiments with this. We've asked, how does performance degrade as you go like 2-3 months out from the time of your training data? And we've asked, how does performance improve if you add, 2, 3, 4 past months into the training data? So like, do you give the model a longer history to learn from? And do you give, how far out can you predict? And it varies a lot by campaign, as you might expect. So the Venezuelan stuff, there's very little performance degradation as you go out in time until they like completely change strategy, at which point you lose tracking almost completely on their activity, which is why the train on the first release, test on the second release for Venezuela looks so different. They're just like completely different campaigns in terms of how they're engaging. For the Russian activity, it degrades smoothly. So the further out you go in time, the lower your performance, but it's not like there's like a sudden drop off. It kind of like, it drops off nicely. What's in some ways more interesting is as you extend the training period back in time, it doesn't always help. And sometimes it hurts. And that's because what they're doing is dynamic and in response to changes in political events. And so there's not like, when I think about, a lot of the other papers on kind of like troll detection kind of think about like an approach or a set of features. And I don't I don't think that's actually right. I think the way they're engaging is they've got some manager who's tracking their performance and is thinking about standard performance metrics, and he needs a way to figure out, like, does this person merit a raise this week or not? Are they doing good work? So he's got to standardize a little bit. And he's got some contextual knowledge about what he thinks is going to work or not. And like one day he's going to get some bright idea like every manager does and come in and be like, hey guys, switch to this. And they're going to pivot. And so the thing which distinguished them in the previous month or 2 months ago is no longer going to work. And so I think there's inevitably some half-life. We are experimenting with some things to do in machine learning to reduce that. And that'll be like the second paper we kind of write up on this. But what I can tell you is, like, loosely in this back testing, performance is still pretty good in the sense that you could generate reasonable confidence intervals on an aggregate estimate of topics they're talking about in volume of activity out to about 3 months from your training data. And again, that's before we've put really any effort into optimizing the machine learning. So I think we could do a lot better. Your second question, though, I think is a subtler one, is like, in practice, would this like let them evade it? And I think the answer is no, because like to move politics, it will always be true that they either need to say something new or they need to say a lot of it. And both of those are always going to leave signal that you can pick up. Because to say a lot, you either need to automate or you need a bunch of low-skilled labor. And that is going to leave signature. And if you want to say something different, that by definition is going to be detectable in content. And so I think there's just this like kind of like hard limit that they face in terms of evading things like this. And so I think the way to think about this kind of thing becoming public is not like they're going to be able to like magically get around it, but you're just imposing a tax on their activity. And that's kind of how we regulate all kinds of public bads.
All right, so I think we've hit our bewitching hour. Thank you so much for the great talk. You're getting a thunderous round of applause through the internet. And I'm sure if you think of other questions, I'm sure Jake will be willing to answer them later. And so get a hold of either him directly or me if you don't know how to get a hold of him, and we'll make sure it happens. Otherwise, stay tuned for same station, same time next week. See you all soon.
Awesome. Thank you, Kathleen. Thank you, everyone.
Thank you, Professor.